Hello and a very warm welcome to you as you join us for this Paramics Microsimulation workshop. My name is Malcolm and I'm the Director of Paramics Microsimulation based in Edinburgh in Scotland, and it's my great pleasure to be able to join you today and share with you some more great content all about Paramics. Now, this is the 6th workshop in our series. We ran the first 5 in the months of May and June and then have taken a break over the summer, and now we're back this month with several more workshop sessions looking at new features, best practice and case studies. Now, in the session today we're going to be looking at more new features coming to Paramics Discovery 24, which will be launched in just a couple of weeks' time in this month of September 2020. So let's dive right into today's session. So the first feature we're going to look at here is parking in Paramics Discovery. And there's 2 aspects to this. One is on-street parking, which you can see happening on the screen in front of us, and the other is car parking or off-street parking. So we'll take a look at both of these. Now, to demonstrate the on-street parking first, I'm going to use this model in front of me, and if I right-click on it and go to Map, I can see where the location of this model is. And we can see it's the town of Douglas, which is on the Isle of Man. Okay, now if I zoom into the town a little bit more, I can see how parking is used within the town. And I happen to know there's a lot of parking along the promenade here. If I go to the satellite image, I'll be able to see lots of cars parked along the side of the road. So you can see that there, and it goes right up the street. Lots and lots of cars parked on the side of the road. Okay, so let's see how we can reflect that in the model. Now, here's the promenade area within the model, and there's a zone 51 there, which you can see faintly. Now, before we had this parking feature, what we did was we set vehicles to destinate on those links in that zone, and that represented the vehicles that were parking. So it's a good representation, but it didn't actually model them directly. So let's look at how we can model them. I'm going to select a link, and by right-clicking and going to Properties, I can now see an option in my Properties at the bottom there called Parking Type. And I've got 2 options, parallel or perpendicular. So I've chosen parallel, and I can see there a series of parking bays that are parallel to the street, and that's automatically created those for me by setting that property on the link. I'll select another link and choose perpendicular, and you can see I've now got perpendicular bays, and we can get more of those in on a link because they're perpendicular rather than parallel. Now, a lot of the bays in the Douglas model on the promenade are perpendicular, so I'm going to select several links here, and in the properties I'm going to set those to perpendicular. And we can do that all in one go on several links, and you can see those parking bays being created along that link. So that's the parking bays created on the links. The next step then is to consider how the traffic is going to be distributed to arrive at those parking bays. Now, if I select Zone 51, I can see that it's currently using 2 zone portals, and that's those 2 entry and exit links that are going in and out of Zone 51, and it's just split 50% between the 2, so that's how it's working at the moment. Now, what I want to do is move the zone portals to the links with the parking bays on them. So if I select Zone Portal 1, I'm going to select a series of the links with the parking bays, and I'm going to deselect the links that are currently sitting in Zone 51. And I'm going to do the same with Zone Portal 2. Select Zone Portal 2, click on the link for that portal, and deselect the links that are currently in Zone 51. So now all the traffic going to Zone 51 is going to be parking in those parking bays rather than going into the links within the zone. Now, I'm just going to shift the demand percentages a bit because my parking bay for Portal 1, or my series of parking bays, is slightly more than 2. So I'm going for a 70-30 split there and saving that. Okay, in the Visualize tab, if I refresh and get the simulation going, I should now be able to see vehicles parking. You can see the parking bays there, and just to say that in the Styles panel you can turn them on or off using car parks. Okay, so the simulation running, I'm getting some traffic on the network, and I should now see that traffic which is destinating at zone 51 using those parking bays, and I've got one vehicle in there already. Now it's just going to be choosing a bay at random on each of those links, and you can see those are just randomly selected, and the vehicles will drive front end in to the parking bays, or they'll reverse in. They can do both maneuvers, and again they will just choose the maneuver at random. One of the really good things about this is it will have an impact on the rest of the traffic on the network as those maneuvers take place. Now, I'm just opening up the vehicle marking here because I'm going to highlight all the vehicles going to zone 51 in green, and that's going to help me identify exactly which vehicles are going to the zone, which vehicles are parking, and then I can watch that behavior in a little bit more detail. So if I run the simulation on a little bit further, try and catch a green vehicle, there's one, and select it. Yep, it's going to zone 51. Now I'm going to zoom in on that vehicle and just watch the maneuver, and you can see a really nice smooth maneuver as it pulls into the parking bay that it has chosen, and there's another one just below it as well. Okay, we'll catch another green vehicle here. We're just watching it as it travels through the network. It's searching for a parking bay that it's going to use, and when it does, we'll see that maneuver taking place. And there it goes, pulling into the parking bay. Okay, so we can see as the simulation continues, there are lots of vehicles filling up that parking bay, the green vehicles that we marked. But there's also parking bays that are empty. Now the reason for that is because we put 4 of these parking bays into the same zone portal, and because most of the traffic is coming from the north, it's filling up that first link because it's a slightly shorter route and therefore lower cost. So what I'm going to do is I'm going to remove 3 of the links from zone portal 1, and I'm going to give each of those links to the southern section of this road their own zone portal. And that means we'll be able to distribute the traffic more evenly to each of these parking areas. So with a zone portal on each link, I'm going to add a demand percentage for those. I'm just guessing this based on the number of parking bays on that link, making sure the total sums to 100, and then I can save that and rerun the model and check that I'm getting a distribution across those parking bays. So go to the Visualize tab and refresh, and we'll start the simulation going again. Now, one thing to be aware of as well is that the trips arriving at a parking bay are different from the trips that leave. So once a trip has arrived and parked, it's officially destinated at that zone. Then when a trip is due to leave that zone, it will pick up the parked vehicle and use that. So we are talking about 2 separate trips, even though it often looks like it's the same trip because it's using the same vehicle. Okay, I can see that I've got a vehicle parked in one of those new parking bays, so I think that distribution is working well. Now the final thing to just highlight here with this feature is that as the parking maneuvers take place, they will affect the rest of the traffic on the network, and that can be really useful in creating that urban environment and urban delay that often happens on road networks. So when a vehicle is pulling out of a space or pulling into a space and needing to slow down to do so, it means the traffic around it will also have to slow down. So you can see as that red car pulled in, and now as that blue one pulls in, the surrounding traffic is needing to react and respond in accordance with that parking vehicle. Okay, so that's everything for on-street parking. Let's now have a look at off-street parking. So to demonstrate off-street parking, we're going to use the same model again of Douglas Town Centre. I'm going to return to the map here so that we can have a little look at the town and where some of the off-street parking is actually located, and then we're going to use that for this demonstration. So I'm zooming in again quite near the seafront, quite near the promenade where we've just looked at the on-street parking, And I can see on the satellite image here, there's quite a few different car parks where we can model the off-street parking that takes place in Douglas. So I'm going to focus in on this area, which is the quayside parking lot, and zoom into that location within the Paramics Discovery model. Okay, so I've got my 2 links coming into this area currently, and similar to the on-street parking, those links were representing the vehicles arriving at that car park and parking there without modeling them explicitly. And again, it's using zone portals to do so. So I've got 2 zone portals and a 70-30 split between those 2 in terms of arrivals, and they all leave from the link to the south edge of that car park. So that's the only exit available. Now for my off-street parking, the first thing I really need to do is actually create the network, the car park network within the area. So that means adding in several more links into this area. So I'm just going to do that first of all. And if you're not that familiar with the new adding links tool, it's very, very easy to use by selecting the toolbar at the top and either joining nodes together or and you can see the merge node which came into version 23 there, or by creating links in their own right. You can also split a link, which is another really easy thing to do, and build up the network in that way. Okay, so there's a basic structure of the car park that I'm going to be representing in this quayside car park for this demo. Now, the next stage then, similar to the on-street parking, is assigning the links to the zone portals. Now, we learned last time that the best way to do this to get the distribution that we want is to create a zone portal for every link that we want car parking to take place. So I'm going to add several more zone portals here, and each of them is going to be associated with one link. So I'm starting at the top of the car parking network with zone portal 1, and I'm working down 2, 3, 4, 5, 6, and then I'm going to put some parking on the end as well, because I can see there's a few vehicles parking on that end of the car park in the satellite image. So if I go back to the model, I'm going to put parking on the 2 ends as well. So this is a key part of setting up your car parking, whether it's on street or off street, is associating it well with the zone, in this case zone 45, and using zone portals to get that distribution. Now once the zone portals are created and associated with each link, we can then go in and change the demand percentages to get a suitable distribution. And similar to the on street, I'm going to be basing the demand percentages on the number of parking bays on that link. So the length of the link as well is a really good indication of how many parking bays will appear. Okay, so having assigned the links to the zone portals and got my distribution across the links, I now need to select all of the links and create parking bays on them. So I can do that by holding Control, selecting multiple links, right click and go to Properties, and then set the parking type to perpendicular. And most car parks that are off street will be perpendicular parking. Now you can see that the parking bays there, which are a standard size, are overlapping one another, so that's not ideal, but it's very easy to fix that simply by moving the nodes around within that link structure that I've got to represent the car park, and I'm just going to separate those parking bays out from one another and try and get the bays in suitable positions before I look at the visualization of the car park itself. So you can see just by simply clicking, dragging and moving those nodes, it's very easy to get those bays into a suitable position once again, and it automatically moves those when I move the links. Okay, so I'm pretty happy with that now, and I can save that, and then I'm going to be looking at visualizing the parking on in this area, in this quayside car park. So in the Visualize tab, I will refresh. It will populate the parking area with those parking bays, and then I can start the simulation and get some traffic running. Okay, so traffic's running in the simulation and vehicles are now parking in these parking bays, and we're going to be getting that distribution of traffic based on the distribution that we set up for the zone portals. And you can see that vehicles are moving in and moving out of the car park, and just like on-street parking, they're using the different maneuvers of moving forward or reversing out of the car parking space. And here we can see the operation of the same park in 3 dimensions. Now, as with on-street parking, the vehicles that are arriving at the car park are destinating at that zone, in this case zone 45, and then the vehicles that are leaving the car park will be picking up a vehicle that is already parked, but it will be a new trip going to a new destination. So although it looks like the same vehicle, it's actually 2 separate trips, the one arriving at the car park and the one leaving. Now, another thing just to be aware of with the car parking feature within Paramics Discovery is that vehicles will only park on the side of the road that they're driving, so they won't cross the road to park in a different space. So you have to be aware of that as you set up your car parking system, that vehicles will need to park on the same side of the road as they are driving, and you can see that taking place as they move in and move out of those spaces. So the next feature that I'd like to demonstrate today builds on one that we already looked at in a previous workshop session, and it's using the incidents feature, but today we're going to look at a couple of new applications for this. And the applications we're going to look at using the incidents feature are the ability to do deliveries and also the ability to do drop-offs and pickups. Okay, so I'm going to use the model in front of me for this example. Now, a very good application for drop-offs and pickups, which you might come across in your models, is a school. Because at a school, you'll often get parents dropping their kids off, stopping their vehicles for a short duration on the road, and then driving off again. And that will happen multiple times within a short time period when the school's opening or closing. So we can see how that's reflected in the incident here on the screen. The incident's located on this link, which is beside the school, and we added that incident in the same way as we did in the previous example, so I won't go through that bit again. You'll see that we've set up the earliest start time as 8:20 to finish at 8:30, so that ties in with the start of the school day at the school, and we've got a minimum duration of 10 seconds and a maximum duration of 20 seconds to represent the time that vehicles will stop to do the drop-off, and there's 15 occurrences in there. So previously we just looked at one occurrence of an incident with a breakdown or an accident, but now we're looking at multiple occurrences that can happen within this time frame. And all the vehicle types are cars, as that's the type that's used for school drop-off. This is the AM period, but if it was the PM, then it could represent children being picked up from school, and the behaviour would be similar in that vehicles were stopping to pick the children up and then moving on. Now, the second incident we're going to look at here is a newsagent delivery. So this is where we have a vehicle driving to a newsagent early in the morning and dropping off, let's say, some newspapers, and it parks there for a certain amount of time and maybe blocks the road and affects the rest of the operation of the traffic, and then it will move on. So we're saying that this incident will happen between 8:10 and 8:20 in the morning. It's for a minute to a minute 30, and we've just got one occurrence. And we've set the vehicle type to a light goods vehicle because that's the type of vehicle that does this delivery. Okay, so those are the 2 incidents that we've got set up in this model to represent 2 different types of behaviors. So let's have a look at these 2 in action. So I'm going to go to the Visualize tab, refresh the network, and start the simulation, and we'll have a look at the newsagent delivery first of all. Now, the incident said it would happen between 8:10 and 8:20, so let's have a look if we can see that incident occurring. And you can see there the incident has happened at 17 minutes past 8, so it's picked up a light goods vehicle and it's randomly assigned at a time between 1 minute and 1 minute 30, and as we've paused the simulation there, you can see that countdown clock going through and the light goods vehicle is blocking the traffic behind it, and so it's having an impact on the operation of the network and the delay on the network due to that delivery at the newsagent. So that's that example. Now if we go and have a look at the school, and we know that this is happening from 8:20 to 8:30, so we can start the simulation again, and we should now start to see cars stopping to represent children being dropped off at the school. And we can see there's the first one there, and the car stopped, and it's stopping for between 10 and 20 seconds, which is what we set up in the incident. So as we watch this from 8:20 to 8:30, we should see several cars stopping during that time. So slightly different to the delivery, which was one vehicle, we're now getting this incident occurring several times. And again, there's going to be a resulting delay on the network with this incident in place. Okay, so hopefully that gives you a bit more of a sense of how incidents can be used. Previously, we looked at just one vehicle being stopped, one incident occurring, and quite a major incident. And now we can see how incidents can be used to create multiple occurrences, but also to create what we might call minor incidents, short stoppages in the road that just add to the overall behavior of the network and the traffic on the network and improve the validity of our models. Okay, there's one more application I'd like to demonstrate today, and it draws on the two features that we've already looked at, that's car parking and incidents. And it's using those two features to be able to model two examples of electric vehicle charging. Now, electric vehicles is a growing share of the driving fleet on our road networks, and we know that many countries have emissions targets that mean electric vehicles are likely to increase in share on our roads. And so electric vehicle charging could play a much bigger part of our networks. So this is going to show you two examples of how you might represent electric vehicle charging using the features available. Now the first one, I'm going to use this test model in front of me, and you can see it's a very simple model. Zone 1 is got traffic feeding into the network, and we've got several links with parking bays on them. So it's essentially representing a car park here, just like the off-street car park that we looked at in Douglas Town Centre. And what we're looking to do here is say that part of this car park is going to be used for electric vehicle charging. And so we want electric vehicles only to park there so that they can charge in this car park. Now let me zoom out a little bit, and I'll show you how we're going to do this. You can see there's two zones, destination zones in this car park. Zone 2 has several zone portals. Each zone portal has its own link with parking bays on it. And you can see the distribution of traffic, which is simply represented by the number of parking bays in each of those links, just like we did with the off-street parking. Now we've also in this model got zone 3, and zone 3 has its own specific link and specific parking bay, and that's because zone 3 is going to be used for electric vehicles only. So all the other cars are going to go to zone 2, but the electric vehicles are going to go to zone 3, and we're going to be able to see them visualized in those parking bays. Now to do that, we need to have a specific electric car's vehicle type, and you can see I've created one at the bottom of the list here. The properties of this vehicle type are just the same as the normal car in this case, but of course you can set the properties to be whatever you want them to be within that dialog. Then if I have a look at the Edit Demand tab, we can see that there's two different matrices at work here. Matrix 1 has trips going from zone 1 to zone 2, and so that's for all of the standard petrol and diesel cars. And we can see then if we click on matrix 2, we will have trips going from zone 1 to zone 3, and that's our electric cars. And they're much fewer electric cars, just 10% of the fleet, of course, because there's fewer on the road network and fewer parking bays for them. If we look at the vehicle type proportions, you can see that all of matrix 1 is the standard cars, and all of matrix 2 is the electric cars. So that's how we've separated them up within this model. So that's how I've set my network up, my zoning system and my demand. And now if I go to visualize and refresh and start the simulation running, we'll just make the background color a little bit darker so we can see those parking bays. And I'll slow it down to 20 times real time and get the simulation running. Now I have set the electric cars to be green, so they're either a light green or a dark green color, and that's how we can distinguish them from the standard cars. And what we're able to see in this example is that the green cars are all going to go to the link in the top right, and that's for electric vehicles only, and all the other cars are going to all of the other links. And the second example of electric vehicle charging I'm going to demonstrate uses the incidence feature. And I'm going to use the model in front of me to demonstrate this. Again, it's a very simple model. We've just got zone 4 on the left hand side going to zone 5 on the right hand side along a series of links, and we've got 3 electric vehicle charging bays on the road. Now this is going to use the incidence feature, which means we don't get the parking behavior which we did in the last example, but the benefit is that we can set the time that vehicles actually stop and charge for in the parking bays. So if I zoom in on those a little bit more and have a look at the incidence, I can see how this has been set up. So we can see that we've got 3 incidents. I've just called them EV1, EV2 and EV3. They're all the same. And what we're saying here is that between a certain time, a vehicle is going to be identified and it's going to stop. We've said between 8 and 9 in the morning. And we're giving it a minimum duration of 1 hour and a maximum duration of 1 hour 30. So it's quite a long time compared to the instance that we used in the other example because of the charging. And of course, we're using electric vehicles as the vehicle type. And you can define whatever properties you want, of course, within the instance dialog. These seem to be suitable settings for this demonstration. So I'm going to close that. I'll go to my visualize and we'll refresh that and set the simulation going. And hopefully a vehicle is going to be picked up soon, and we can see there that an electric vehicle has been identified and it's gone into the charging space for 2. And we can see in the countdown clock that the time that it was set must have been close to the 90 minutes, which was the maximum time, because it's currently at 85, and that will be counting down. So that vehicle is going to sit there for quite a long time as it charges before moving on its journey. And if we keep the simulation going, then hopefully we'll get vehicles appearing in the EV1 and the EV3 slots before the time expires. I'll just speed the simulation up to catch them, and we've got them there. And so you can see all of the 3 electric vehicle charging points are full, and we can see all the vehicles are green, meaning they're electric vehicles only, and they will move on once their time expires. Now you'll see the hatched green lines I've got in there. That's simply a restriction for electric vehicles, and that controls the vehicles that will go into those bays, and it's restricted to electric vehicles only, and so we won't get any of the standard cars going in there. So thank you so much for joining us for this Paramics workshop today, where we've looked at some more new features coming to Paramics Discovery 24, which is going to be launched in just a couple of weeks' time, September 2020. Now the features we've looked at today of car parking and incidents are really, really powerful, and I hope that they're going to open up new applications for you as you use Paramics Discovery in the future. If you've got any comments or questions about them, please leave them in our feed and we will be glad to get back to you. We're going to be back for another workshop session at the same time next week, and we really look forward to seeing you then. Bye for now.